Welcome to Educator.com. In today's lesson, we'll be working on solving polynomial equations. And we're going to start out by reviewing some factoring techniques. And the techniques that you'll use for factoring polynomials are familiar from earlier work. And these include greatest common factor, difference of two squares, perfect square trinomials, general trinomials, and factoring by grouping. So just as we did with quadratic equations, if you're going to be working with a polynomial, the first thing you want to do is if there is a greatest common factor, factor that out. Factor that out first. For example, if I had something like 4x to the fourth minus 6x squared minus 12x, I have a greatest common factor of 2x. So I'd pull that out first. And that would give me 2x, leaving behind 2x cubed. Here, that would leave behind 3x. And here, negative 6. And then I would work on factoring that farther if it's possible. Okay, difference of two squares. So this is greatest common factor. And now difference of two squares. Recall that these are in the form a squared minus b squared. And an example would be x squared minus 9. So this could be factored out into x plus 3, x minus 3. So this factors into a minus b times a plus b. Here, in this case, a equaled x and b equaled 3. X squared minus 3 squared. Okay, in a few minutes we'll actually be talking about the difference and sum of two cubes. So we'll go on a little farther than just working with squares. Next, perfect square trinomials. You know that if you recognize these, that they're easy to work with. So you want to be on the lookout for these, perfect square trinomials. For example, one that we've seen earlier working with quadratic equations is x squared plus 8x plus 16. And this factors as x plus 4 squared or x plus 4 times x plus 4. So perfect square trinomials. And all these are covered in detail in earlier lectures. So go ahead back and review these if necessary to make sure you have them down before you work on factoring polynomials. General trinomials. These would be, you would recognize these in a form that they don't fit into the special cases of difference of two squares or perfect square trinomials. So it might be something such as, say, x squared plus 2x minus 8. And you need to just use some trial and error on this. And for example, for this one, you would say, okay, the first term in each factor has to be x. And since I have a negative in front of the constant here, I have to have a positive here and a negative here, because a positive times a negative is going to give me a negative. Then I'm going to look at the factors of 8. And I'm going to say, okay, I've got 1 and 8 and 2 and 4. And then I want to find factors of 8 that when one is positive and one is negative, they sum up to 2. And I can see that 1 and 8 are too far apart. They're never going to give me 2. 2 and 4 are perfect. And I see that if I make the 4 positive and the 2 negative, I'm going to get 2, which is going to be my middle term, the coefficient for my middle term. So this is going to factor out to x plus 4, x minus 2. And I can always check this by using FOIL, which will tell me that first term gives me x squared, outer is negative 2x, inner is 4x, and then this is negative 8. So x squared plus 2x minus 8. It gave me this trinomial back. Grouping. Recall that we use grouping when we're factoring polynomials with 4 terms. So factoring by grouping. So let's say you have something such as 3x cubed minus 4x squared plus 6x minus 8. I'm going to handle this by grouping the first two terms and then grouping the second two terms. Now, I'm going to pull out any common factors I see, and I do have a common factor of x. Actually, x squared, to leave behind 3x minus 1. Over here, I have a common factor of 2. I'm going to pull that out, and that's going to leave me with 3x minus 4. I'm pulling out the x squared, that's going to leave me with 3x minus 4 here. Here, I'm going to pull out the 2, that's going to leave me with 3x minus 4. This is what I wanted to happen, and what I have here is a common binomial factor. I'm going to factor that out, pull that out in front, and that leaves behind x squared plus 2. So factoring by grouping, group the first two terms, group the second two, pull out a common factor. If you have a common binomial factor left behind, then you pull that out in front. So make sure you are familiar with all of these, review the ones that you need to, and we're going to be using these to solve polynomial equations. Now going on to a new concept with factoring, and that is the sum and difference of two cubes. So you're familiar with working with squares, and now talking about the sum and difference of two cubes. Let's look at an example. 64x cubed plus 125. Well, if I think about this, the cube root of 64 is 4. The cube root of x cubed is x. The cube root of 125 is 5. So here, this is in this form, a cubed plus b cubed. Here, a equals 4x and b equals 5. Now, by memorizing this formula, I can just factor this out. So if I know that this is in this form, a cubed plus b cubed, which equals a plus b times a squared minus ab plus b squared, then I know that I've got a is 4x and b is 5. So I just have to substitute that in. Here, I'm supposed to have a squared, so that's going to give me 4x squared minus a times b plus b squared. Okay, this is 4x plus 5, and this is going to give me 16x squared minus 20x plus 5 squared is 25. Okay, so again, just recognizing that this is actually the sum of two cubes, so it's going to factor out to this form. For the difference of two cubes, very similar idea, only you're going to end up with a negative sign here and a positive here. So same idea, just different signs. So 64x cubed plus 125 factors out to this. And then from there, in some cases, you may be able to go on. Okay, so with your factoring. Let's talk about quadratic form. So we worked with quadratic equations earlier on, and you can actually put higher order polynomials into a form called quadratic form. And quadratic form is an squared plus bn plus c, where n is an expression of x. Well, what does that mean, n is an expression of x? Let's use an example. Let's say I have 6x to the 8th plus 5x to the 4th plus 9. And I want to get it into this form. An squared plus bn plus c. Well, let's look at this more closely. I want to get this into some form where I have a number squared. So I have a square here. Now, I'm going to think about x to the what squared equals x to the 8th. Thinking about raising to a power to a power, I know that I have to multiply 2 times something to get 8. So 8 divided by 2 is 4. So that tells me that x to the 4th squared is x to the 8th. So all I did is I took my x to the 8th and I put it in a form where it's something squared. Now, I'm going to assign another variable this value x to the 4th. I could use y, I could use z. I'm going to go ahead and use y. I'm going to let y equal x to the 4th. Therefore, y squared equals x to the 8th, since y equals x to the 4th. Because if y equals x to the 4th, I could just substitute and say that this is really x to the 4th squared. Okay, so again, what I did is I looked at what I had, x to the 8th, and I said, what would have to be the exponent in here so that I could just square it and get this back? Well, the exponent would have to be x to the 4th. Then I took this and wrote it as a different variable. Y equals x to the 4th. I assigned the variable y the value x to the 4th. So that's what this means, something n squared. Here, I'm just going to say it's y. So this gives me, my leading coefficient is 6. Now, instead of putting n, I've decided I'm going to use y to represent x to the 4th, and that's going to be y squared. Plus, my next coefficient is 5. Okay, here I have an x to the 4th, but I said y equals x to the 4th. So I'm just going to write it as y. And then my constant. So now I've taken this and rewritten it as this equation where y is equal to x to the 4th. Now that this is in quadratic form, I can use techniques such as the quadratic formula and factoring learned earlier on in order to, if this were an equation, let's say, then I could solve it using these techniques for working with quadratics. Once I find the value of y, whatever y turns out to be, if I know y, I can find x. You know, if y is 16, then I would just have to say, okay, this equals 2. Then x would equal 2. So by putting this equation into quadratic form, I can use quadratic techniques to solve for y. Once I have y, I can solve for x, which makes quadratic form very useful when working with certain polynomials. Okay, looking at this first example, 27a cubed minus 8, I recognize this as the difference of two cubes, and this is in this form. So it's in this form. Here, the cube root of 27 is 3. The cube root of a cubed is a. So this is what I've got. The cube root of 8 is 2. Therefore, what I have in here is a, and what I have right here is b. And sometimes it helps to actually write these out instead of doing it in your head, just to keep everything straight. So since I know that a is 3a and b equals 2, I just have to substitute here to factor. So a minus b, I'm going to rewrite it down here, a squared plus ab plus b squared. Okay. If a is 3a, then that's going to give me 3a minus b, which is 2. Here, I'm going to have a squared, so that's 3a squared, plus a times b plus b squared. This is going to give me 9a squared plus 6a plus 4. Okay, and just one important thing is just to watch the signs, you know, working with the difference of two cubes or the sum of two cubes, and then figure out what your a and b values are by finding the cube root of these terms, and then just substituting in a and b into this formula to get the factorization. Okay. In the next example, we're asked to factor this trinomial, and the first step is to factor out a greatest common factor if there is one. And I'm looking here for a greatest common factor. And I see that I have a 3 that can be pulled out of all of these terms. For x's, I have x squared, I have an x here, and an x cubed. So they all have at least an x. For y, there's one y here, there's y cubed here, and there's y squared here. For z, I have z cubed, z squared, and z to the 4th. So they all have at least z squared. So the greatest common factor is 3xy z squared. So I'm going to pull that out and see what's left behind. For my first term, the 3's gone. I'm left with an x. The y's gone, and the z squared's gone. So that leaves me just xz. Here I have a negative sign. I pulled a 3 out, leaving behind a 4. The x is gone. 1y is gone, so I have y squared. Z squared is gone. Here I pulled out the factor of 3. That leaves behind 8. 1x is gone. I've got x squared. 1y is gone. And z squared is gone. Okay, so I'm left with the greatest common factor times what was left behind in here. And I'm looking, and there are no common factors left. I don't recognize this as the difference of two squares or anything that I can factor out. So this is as far as I can go with the factorization. Okay, now I'm asked to write this polynomial in quadratic form. So recall that quadratic form is an squared plus bn plus c. Here I have x to the 6th. So I want this in to find some variable, assign it a certain value, and then square it. So x to the something squared equals x to the 6th. Well, if I take 6 and divide it by 2, I'm going to get 3. Therefore, x to the 3rd squared equals x to the 6th, because 3 times 2 is 6. So I'm going to let y equal x to the 3rd. Therefore, y squared is going to equal x to the 6th, because that would be x to the 3rd squared. Okay, now let's look at what we have. We have our leading coefficient of 10, x to the 6th. Well, x to the 6th is going to be the same as y squared. Minus 12. Now I have x cubed here. Well, I said that y equals x cubed, so I'm just going to put y here, plus 14. So this is my given equation, this polynomial in quadratic form. And again, I did that by assigning y the value of x cubed, which allowed me to write that as 10y squared minus 12y plus 14. I could then use methods for solving quadratic equations. If this were an equation, then I could solve this and find y. Once I have y, I could go back in and just find the cube root of that, which would give me x. Okay, in this example, I'm actually asked to solve the equation. So I'm going to start out by factoring. And this is a trinomial. And again, when you see that x to the 4th trinomial, you could think that it's similar to working with a quadratic, except you've got x squared here in the factors instead of just x. So x squared times x squared is x to the 4th. Okay, so I have negative sign here, which means that one term is going to be positive and one is going to be negative for the second terms. Let's think about the factors of 24, and let's find factors that are going to add up to negative 2. Factors of 24, 1 and 24, 2 and 12, 3 and 8, 4 and 6. Now, this is a lot, but I don't have to work with all of these. I want to find ones that are close together, because their sum is just going to be negative 2. So the closest together are 4 and 6, and I see that one is positive, one is negative. Well, if I make 4 positive and 6 negative, their sum will be negative 2. So I know that that's what I want. I want the 4 to be positive, and I want the 6 to be negative, and this all equals 0. Okay, so I've actually factored this as far out as I can. There's x squared plus 4 doesn't factor any farther, nor does this. So I'm just going to go ahead and use the zero product property to solve. And the zero product property tells me that x squared plus 4 equals 0, or x squared minus 6 equals 0. Because if either of these terms is 0, the product of the two will be 0, and the equation will be solved. So here I'm going to get x squared equals negative 4. Now, when I take the square root of that, I'm going to end up with this. Recall from working with imaginary and complex numbers that the square root of negative 1 equals I. So this is the same as saying the square root of negative 1 times 4, which equals the square root of negative 1 times the square root of 4. So since this equals I, I'm just going to write this as this. And that is actually plus or minus. We have to take the positive and the negative according to the square root property. Okay, well, this is a perfect square, so this gives me plus or minus 2i. So some review of complex numbers. Here, a little bit simpler, x squared equals 6. According to square root property, if I take the square root of both sides, then I will get x equals plus or minus the square root of 6. All right, so I was asked to solve this, and I came up with the solutions, and the solutions are that x equals 2i, negative 2i, the square root of 6, or the negative square root of 6. And I figured that out by factoring this into these two factors, x squared plus 4 times x squared minus 6, and then continuing on to use the zero product property. In this case, I ended up with x squared equals a negative number, so I ended up having to use a complex number for my result. And then these are the 4 solutions to this polynomial equation. That concludes the session of Educator.com on polynomial equations, and I will see you next lesson for more work with polynomials.